This is a mole problem, and we're going to start off by looking at how many moles given the number of particles. And so the first thing that we want to grab onto will be our mole wheel. So we can see that we are starting at 8.2 times 10 to the 24th molecules, and so we're going to start at the particle side of the mole wheel. So since we're starting there, I'm just going to go ahead and write 8.2 times 10 to the 24th, and that's my molecules. And so again, just kind of following the arrows. If I follow the arrow, my first arrow to get to mole says I need to divide, and I'm going to divide by 6.02 times 10 to the 23rd. So I'm going to take the 8.2 times 10 to the 24th, and notice molecules, and I'm going to divide by 6.02 times 10 to the 23rd molecules, and that's going to get me to moles. And so I'm going to show you using a calculator. There is an e-calculator that I need to find really quickly. And so I'm going to show, using that calculator, how to put this in. So if we look, I don't like the fact that it puts a smaller e, but we're going to do 8.2. And I'm going to hit EE. I'm not going to hit a times. I'm not going to hit a 10. And I'm going to put a 24. Notice I put that number in first because I hit it first when I'm given the problem. So the problem will always, the number in the problem will always go in the calculator first. Now I'm going to divide that by, the next number I hit is Avogadro's number, 6.02, E, the EE button, 23. And then I'm just going to hit equals. And so it tells me that my answer to this is 13.62. So I'm just going to round that to 13.6 because I have 3 significant digits, and that's moles. So now I'm at the mole part of my mole wheel. But if we add on, it says, well, how many grams is this? Well, now that I have mole, our little saying is if you have mole, then you can multiply. I'm going to take the 13.6. I'm going to follow down to grams. And so again, I'm continuing on my arrows. And now it says, move my little green marker out of the way, that I need to multiply. So I'm going to multiply by molar mass. So I need to go to the periodic table. And since it says how many grams of, oops, I'm kind of jumping ahead on that, it's CO2. So I need to look that up. Well, carbon on the periodic table is 12, and oxygen is 16, but it's 16 times 2, 32. So the molar mass that I'm going to put right here is 44 grams. So if I have 44 grams, I times that by 44. And that's easy to put in the calculator, so I think you can handle that. And so when I work that out, I get 599 grams of CO2. So I'm going to kind of gather up my answers. So my answers are 13.6 moles and 599 grams. But you need to make sure that you show me the work. You show me the numbers. This is what it should look like when you take your test for the mole question, and then you're going to continue on. You can multiply by 44. And so that's going to help us, and that's going to give us the answers that we need for a basic mole problem. But I noticed that if you add on, it says, how many atoms of oxygen is this? Well, I'm going to go back to my original 8.2 times 10 to the 24th, because I know that CO2 has 2 oxygens for every 1 CO2. I don't have 1 CO2. I have a bunch of CO2. So I'm just going to take 8.2 times 10 to the 24th, and I'm going to times it by 2 to figure out how many oxygens I have. So you put that in your calculator, you end up with 1.64 times 10 to the 25th atoms of oxygen. Just O. This is not O2. It's just the number of O's in there. So that's why I multiplied it by 2. So now the next question is, what is the volume in liters at STP of 850 grams N2 at STP? Oh, I repeated the STP. Making sure you know it was at STP. Because on the mole wheel, we're only allowed to use this 22.4 is if we're at STP. So where are we starting? Well, obviously, we're starting somewhere where we can use 22.4, or we're going to end up where we can use that. So if we look, I have 850 grams. So grams, grams. I'm going to start there. I have 850. That goes in the calculator first. So then I have to divide. I'm heading towards mole. I have to just follow my arrows. So I'm going to head toward moles, and I'm going to divide by molar mass. So now I have to go to the chart and look up N. I know that N is 14, so 14 times 2, so I know it's 28 grams. So I'm going to take my 850, I'm going to divide by 28, and that's going to get me to moles. So when I work that out, I have 30.4 moles of N2. Now I'm here. Now I'm at moles. I'm trying to get, so I'm going to continue to follow my arrows. Oh, it tells me to times by 22.4. So I'm just going to times that number by 22.4 liters. And that's going to tell me what I have, and really what I was looking for, which is 681. So if you work that out, the answer is 681 liters. So again, just following the mole wheel. If we want to write it out neatly, we did 850 grams. We divided by 28, and then we multiplied by 22.4, and our final answer was 681 liters. If I'm not asking for mole, you don't have to stop and do that step. You can just keep going. So just follow your arrows, do what it says. The answer is 681 liters. If you want to stop, go right ahead. Go right ahead and stop. So that's our answer for number 2. Now number 3 here, we have a little problem. I'm not at STP. So whenever we're not at STP, we have to use the formula. We have to use what's called the ideal gas law. So this is called the ideal gas law. Well, notice what I'm looking for. It says, what is the volume of 850 grams of N2? And it gives me some things. It gives me 28 degrees Celsius and 0.74 atmospheres. Well, here's my formula. VP is equal to nRT, and I'm looking for volume. So what I'm going to do is I'm going to take P, and remember a little saying that whenever you're moving a variable around, if it's on top, it moves to the basement on the other side. So I'm going to divide nRT by P. So as long as I have my numbers, I can just plug it in, and so I can plug and chug. So it says, what's the volume? So that's my question mark. R is the ideal gas constant. What's important about R is its units. It's 0.0821. It's a constant. That's always R. It's liters, atmospheres, per Kelvin mole. It's basically our cross-off station. So when we plug R in, it allows us to cross off everything we have and end up with what we want. Pressure, it tells me, is 0.74 atmospheres, and that's good because R, notice R is in atmospheres, and then T, we have a problem because T is in Celsius, but R is in Kelvin, so I have to add 273, which then gets me to 301 Kelvin. N is number of moles, so this is my moles. Well, what's nice is we did 850 grams of N2 in the last problem. So if we look, and we work that out, we did 850 divided by 28, and we got 30.4 moles. So I know my N is 30.4 moles. So now all I have to do is plug in. So volume is equal to N, 30.4, R, 0.0821, liter atmosphere per K mole, times my T, which is 301 K, and then divided by P, which is 0.74 atmospheres. Now what I'm going to do is I'm going to cancel everything out to make sure I end up with a liter, because that's what I need for volume. So moles are gone, K is gone, atmosphere is gone, and the only unit left is liters. And my final answer on that, if I look it up, is 1,015 liters.